Okay, let's look at problem 2. So problem 2, it has a precast concrete wall section is temporarily held by two cables. So you have a wall. Look at this. There is a wall A, B and F, which is the same point, C and O. This wall is a precast concrete wall. Section is temporarily held by two cables as shown. Knowing that the tension in cable BD and BD and FE. So you have cable. Look at this. There's a cable, a wire cable, BD, another cable, FE. So he gives you the tension in cable BD and EF are 900 Newton for BD and 675 for AF, respectively. Determine the moment about point O of the force exerted by cable BD and cable EF. So he wants to know the moment about point O of the force. Moment about point O. So this force,
How many was this ago?
this tension will have a moment around point O. So our objective is to find this tension. Now, let's find the coordinates. Since we're going to do everything about point O, look at this, about point O, we need to find the coordinate of point O. Point O is at 0, 0, 0, x, y, z. Okay? So we need to find this point first. We find the 0, 0, 0. Now, B, what's the coordinate of B? You can see that it has a coordinate of, what is the x? The x is that way, so it's going to go that way. If you're going to go from the 0, it's going to go that way. That's 2.5 in the x-axis. Look at that. And you're going to go in the y, you're going to go up. You're going to go down 2.5 and up 2 in the y. So 2.5 and 2. And in the z, it is, look at this. It is at the 0 z. So it is not in the positive z or the negative z. So it is 2.5 and 2 and 0. Now let's look at point D. Look at D. D is 2.5 minus 1 because 1 is here. So you want to know the distance in the x-axis. It's almost 1.5. So 1.5 in the x. And how about the y? You can see that the D is at the level, the floor level. So y should be 0 because y is going to go up like this in the positive and negative down. Since it's in the floor, y is 0. But z is not 0 because you can see it's going that way. So you can see that's 2 meters from the 0 to here. That is z. So it is 2 meters. So 2 meters in the z. Now, since we have the coordinate, now everything would be easy. Now let's find the vector BD. The vector BD. BD, you go from D minus B, since it's going to be vector BD. So 1.5 minus 2.5. It is minus 1. I. 0 minus 2. 0 minus 2. So it is minus 2. 2 minus 0. It's, of course, minus 2j and plus 2k. The whole thing is in meters. Now, this is the vector. Let's find the magnitude of BD. The square root of minus 1 square plus minus 2 square plus 2 square. Its BD is equal 3 meters. Now we have the vector form of BD and we have the magnitude form of BD. Now we find the tension BD. The tension BD in a vector form is equal the magnitude TBD, which was given. He gave you the TBD. BD was given 900 Newton. Okay, so the tension TBD, the 900 Newton, times the vector form of BD, which is this one, over the magnitude of BD, 900 Newton, times the vector form, minus 1j, minus 2j, plus 2k, over 3 meters, the magnitude. So you just play with this equation and find out the last answer. The tension BD is equal minus 300I, minus 600J, plus 600K. We are done from this. Now we need to find the moment. This is the tension. Now we need to find the moment of this tension around point O. Okay. Now, what is the distance? Let's take one of these. Let's take point B. You could take point D if you want to, but let's take point D. What is the distance between B and O? Since everything gonna be around point O, so what is the distance between B and O? Of course, O is 0, 0, 0, and B is what? B is given here, 2.5, 2 and 0. So 2.5 minus 0, it's 2.5i. And 2 minus 0, it's 2j. 0 minus 0, nothing. There's nothing in the k. So this is the position vector, RBO, which is the distance between B and O, the position vector. We need that for the moment. Okay? Now, since we found the position vector from B to O, now let's find the moment. Moment BD around, moment BD around O. Okay? So we do it like this. The position vector RBD or RBO times the tension BD. We put it like this, MBD IJK. You put the position vector 2.5, 2, and then in the K there is 0, 2.5, 2, and 0. And then we put the tension BD, minus 300, minus 600, 600, minus 300, minus 600, 600. Well, we have to solve this. First of all, we put I. We put it like this. We hide I, and we put here I. So, what do you do? 2 times 600 here. Minus 0 minus 600 is 0. All done. Now, the J has to be minus J. So you put like this. 2.5 times 600 minus 0 times minus 300, 0. And then now it's going to be plus K. Remember, it's I minus J and plus K. We put like this, hide the K. 2.5 times minus 600 minus 2 minus 300, which is going to be plus 2 times 300 because minus. So the moment of BD around point O is equal to, once you just resolve the whole thing, is 1200 I minus 1500 J. Of course, the unit going to be Newton meter, minus 900 K. The unit will be Newton meter. This is the unit of moment. So now, this is what? This is the first things. This is the moment. This is the moment about point O of cable BD. Now we're going to do the same thing for cable EF. Cable EF. We'll do the same thing. Well, of course, point O, we know it. The coordinate 0, 0, 0. The coordinate. Now let's find coordinate F. Coordinate F is similar to coordinate B. It is 2.5, that way in the X. It's 2, and in the Z, since it's at the 0, 0, Z, it's not positive, not negative, it's 0. So 2.5, 2, 0. Now let's look for E. E, look at this. E in the X is 2. It's positive 2. In the Z, E, in the Y, E is in the floor. So Y is 0. E is in the floor. Now Z, you can see that it is going 4. But look at this. This is the positive Z and this is the negative Z. So it's going minus 4. So it's minus 4 for the Z, for E. Now, let's find the position, let's find the tension, the vector form. Let's find the vector form of FE. So, since it's FE, so E minus F. E minus F. 2 minus 2.5 is minus 0.5i. 0 minus 2 is minus 2. Minus 4 minus 0 is minus 4. So you do the magnitude, 0.5 square, plus 2 square, plus 4 square, all of this under the square root. The FE magnitude is 4.5 meters. Okay, now we have the vector form Fe, we have the magnitude Fe. Now let's find the tension Fe, vector form. The tension E vector form is equal magnitude of the tension times the vector Fe of the vector of Fe over the magnitude of Fe. Vector of E, we have it here. The tension of Fe, it was given in the example, 675. The magnitude of the vector form of Fe is given 4.5. So now we just like rearrange this equation, you're going to get tension Fe. This is the vector form of tension Fe, minus 75 Newton I, minus 300 Newton J, minus 600 Newton K. So we have all of this now. Of course, tension are in Newton. Now let's find the tension, the moment of that tension, Fe around or about point O. So we'll do the same thing. We should find the position vector. The position vector between FO. F and E have the same thing, so we're going to have the same position vector for F. So F is 2.5, 2 and 0, because they 2.5 minus 0, 2 minus 0, and 0 minus 0. So it's 2.5, 2 and 0. Of course, for the moment, Fe around point O, we have to put IJK, 2.5, 2 and 0, and you have to put the tension, minus 75, minus 300, minus 600. Now, to solve this, you have to put I here, hide this, 2 times minus 600, minus 0 times minus 300, 0, and then put minus J, 2.5 times minus 600, minus 0 minus 75, 0, and then K, hide it, 2.5 times minus 300, minus 2 minus 75, okay? So the moment Fe is equal minus 1200 I plus 1500 J plus minus 600 K. So this is Newton meter, because this is moment, Newton meter, and Newton meter. Okay? Thank you.